This is video 1 of electron configurations, and it's basically just going to be our filling order. Electron configurations tell us how electrons are arranged in the orbitals around the nucleus, and each element on the periodic table is going to have an electron configuration that's specific to that element. Remember that each orbital can hold a maximum of 2 electrons. And Pauli's exclusion principle tells us that if there are 2 electrons in an orbital, they must have opposite spins. So that'll make more sense later on when we get into filling the orbitals. Before we start filling orbitals, we have to know how many electrons each sublevel will hold. So remember that each orbital can hold 2 electrons. So the S sublevel only has 1 orbital, and it can hold a maximum of 2 electrons. The P sublevel has 3 orbitals, remember the dumbbell-shaped orbitals, so it can hold 6 electrons. The D sublevel can hold 10, and then the F sublevel will be able to hold 14 electrons. The Aufbau principle tells us that electrons fill in order from lowest to highest energy. So this diagram here just kind of shows the orbitals from 1s all the way up to 4d, going from lower energy up to higher energy, which is the 4d orbitals up here. So we see that we start at 1s and then go up to 2s, which has higher energy. And then the 3 2p orbitals here are higher than 2s, but they all have the same energy. All 3 2p orbitals have the same energy, so they're on the same level. And they're called degenerate orbitals, meaning they have the same energy. And then we go up to 3s and 3p, and then 4s, and then 3d. So when we were doing the Bohr model for transition metals, we saw that it was kind of odd that we went from 4s to 3d, but now we see that it's because of the energy, and the 4s orbital has lower energy than the 3d orbital. This little diagram here looks really confusing, but it's actually going to be very useful for you for the Aufbau principle, and this is some reference materials that you'll have. So these arrows kind of show us the energy levels in the order that they fill. So we see here 1s, we know that's going to be our lowest energy level, so we follow the arrow up to the tip of the arrow. And then we go back down to the bottom of the next arrow. So the next orbital we'll fill will be 2s, and then we'll keep going in that direction. When we get to the tip of that arrow, we go down to the bottom of the next level. And we keep doing that as we fill 2p, 3s, and then we go down, fill 3p, 4s, and then we go back down here and fill 3d, 4p, and 4s, and so on. So remember that each orbital can hold 2 electrons, so now it's kind of important for us to remember how many each sublevel holds. So for example, if I had an element with 10 electrons, that would be neon. I would start here at 1s, get a different color. I'd start here at 1s and fill the first 2 electrons there. I have to fill 8 more, so now I move on to 2s. I can put 2 in there, and then I go over to 2p. The p sublevels can fit 6 electrons. I have 6 more electrons to fill, so I put those last 6 in the 2p orbital. Now we're going to go back to the Pauli exclusion principle, which told us that if we have 2 electrons in the same orbital, they must have opposite spins. So we look at the example down here, and we see 2 electrons in the 1s orbital. So this represents helium, which only has 2 electrons. So since they are both in the 1s orbital, they have to have opposite spins. So we denote that with arrows. So the up arrow is going to represent a positive spin, and the down arrow a negative spin. So here we see that our first arrow that we put in the orbital is going to have an up arrow, and then if we have a second electron there, it has to be opposite. So we have to have 1 up and 1 down. Our last rule that we have to know to fill electron configurations is Hund's rule, And this tells us that the lowest energy configuration is one that has the most electrons unpaired in a set of degenerate orbitals. And remember, degenerate was just a word to let us know that the orbitals had the same energy. So, for example, we have 3 2p orbitals, and all 3 of those orbitals have the same energy. So if we were filling the 2p orbitals, we would fill in 1 electron in each orbital and then go back and start pairing them up. So in the last slide, I said that the first electron that we put into that orbital had to have an up arrow or an up spin. So when we're filling in these orbitals, if they're unpaired, they're going to have the up arrow or up spin. So this is just an example of it, and this is oxygen. So we see that the 1s sublevel here is filled with 2 electrons. One is up and one is down. 2s is filled with 2 electrons. One is up and one is down. When we get to the 2p orbitals, we have 4 electrons to fit into 3 orbitals. So the first thing we do is fill in the 3 up arrows. We have to put that 4th electron in there, so we go back to this first p orbital and just put 1 down arrow. So here I'm going to do the example for nitrogen. Nitrogen has 7 electrons. So we're going to start filling those in down here in 1s, and we have an up arrow, kind of an arrow, and then we have a down arrow. So that's a pair. Now we have 5 left to fill in, so we go up to the next energy level, which is 2s, and we put 2 more electrons there, 1 up and 1 down. Now we have 3 more electrons to fill in, and those are going to go into our 2p orbitals here. So we start with the first 2p orbital and put an up arrow, and then we keep doing that, and now we are at 7, so now it's filled for nitrogen. So this video was basically the rules for filling the orbitals, and in the next video we'll talk about how to actually write down those electron configurations for the 3 different types of ways to write it down.